uh, explain like the rationale for why I'm trying to present here. So this is based on the research what we are trying to do, a part of a British Council project with few universities from China, Singapore, and our University of Sussex in Brighton, UK. So we are trying to understand what is needed in the manufacturing sector, especially where developed countries are trying to emerge in manufacturing, even though the big manufacturing hub for the world is China, but still China, Vietnam, or Southeast Asia could be like partly now India is also emerging. But what we are trying to understand, like what developed countries need to do in the future, where their focus are, and how they need to configure the supply chain, what kind of innovations they need to do if they wanted to excel in what they do. So I'm trying to share what we did in the past few months with you, and please feel free to stop me and ask questions if you have any. Right. So to start with, I have seen your kind of like the flyer for the webinar, which says knowledge 4.0. So I know you guys all know what is like the different stages of industry revolution that is happening over time. So I'm just trying to take you through where we are in terms of 21st century, what is known as supply chain. Now, because of this pandemic, everybody got to know some of the issues what they have in supply chain, critical issues on the bottleneck, how supply chain has been exposed because people were preaching, practicing efficiency the most than resilience, where the because of pandemic uncertainty, shutdown in a country affected all other countries recently. There are a lot of bottleneck in the existing global supply chains where they have a long lead time, not only in the regular foods, not only in the regular goods, but it also like it affected food supply chain too. So luckily we are fortunate that even though like food supply, even though we had a lot of issues, still the food supply chain is working and there is no issues. So we got issues in terms of medical supply chain at one point of time. Other goods, oil and natural gas supply chain is having serious problem right now in terms of like climate change and others. So there are a lot of ongoing challenges, but still because of technology development, I think the digital capabilities have been developed well in the supply chain to cope up, and they have a right kind of coping mechanisms to overcome these kind of threats, disasters, or whatever it is. So I'm just trying to, in this slide you can see like the different stages of industry evolution in late I think I would say late 17th century or early 18th century. Industry 1, we all know mechanization, steam power, weaving loom. Mechanization revolutionized industry, so which helped Western countries to beat like especially India and China at that time to emerge as a super power countries in terms of productivity, in terms of outcomes. So they are able to dominate in terms of their industrial production was good. And then later we all know about Model T car from Ford Motor Company, especially in early 19th century, I would say late 18th or early 19th century. Mass production, assembly line, electrical energy, this changed the industry sector to a large extent, I would say. So we call industry 2.0, where electrification changed, or I would say revolutionized or helped to emerge the industrial sector, like who are especially which is relying on manual labor the most. When electricity came, I think it enabled the Ford, like companies like Ford, to automate, so not automate, I would say, like to mass produce certain standardized kind of products, or big like vehicles. Later on in mid of 19th century, I would say like 19th early kind of, we say like late 19th century, early 2000, like automation picked up because of computer emergence of computer automation, electronics that supported a lot the industry, and it enabled companies to achieve flexibility, adaptability in addition to mass production. So that is a good thing. What we have seen in early 2000, where several sectors benefited out of this automation. We all got benefited. Like India emerged because of this automation in the early 2000, 20th century, I would say. So what is happening right now? So we talk a lot about 5G. We talk a lot about cyber physical systems, like interaction between machine to machine, and like without human intervention, how the world is going to change and what changes has to be brought into the manufacturing sector, for example. So we call digitalization. So it should be digital, not digitization. It should be digitalization, meaning like machines have intelligence based on the learning and training. It could take action on its own without human intervention, and how to govern those kind of like interaction between machine is a critical ongoing debate in the literature, especially in the digitalization era. So we call digitalization era, which is Industry 4.0, where 5G, they're already in Europe, they have launched 5G. China is extensively using 5G, and the US now, they are supposed to use 5G from yesterday, but they delayed for a while because of aviation industry. But still, it is going to roll, and then when 5G comes in, and then the data speed is going to be like the data speed would be enormous, I would say, like the and it could support a lot of machine to machine interaction. So that is where we are right now. So what is happening? So how the supply chain, still do we need to go and use the age old like of lean practices, or we are only looking for excellence, or in terms of consistent robust processes? We need that. Plus, in addition, we need to adapt, we need to change, we need to come out with some kind of new practices in terms of design, in terms of manufacturing, in terms of selling the product, and how we are going to customize the product. That is going to be a super challenge for companies right now. So what I'm going to do today, I'm not going to talk a lot. So I'm going to take literally like 40 minutes to share like what is high value manufacturing. I hope you guys have heard about this terminology a bit, or you might have Googled and find out what is high value manufacturing. I'm just trying to share what's known about it, and then I will try to say why what we are calling, why this kind of sector need to have a different kind of supply chain, or can't we use the same kind of supply chain? What is missing there, and what are the issues on the supply side, especially from the manpower? We are going to talk more about university supply of meaning. I'm saying how universities or colleges are training manpower to cater to the industry, or the expectations of the industry. And what are the opportunity as an young mechanical engineering graduates? There are plenty of opportunity if you have a digital exposure as well as the core technical knowledge about mechanical engineering. So that's where I'm going to share some of the review what we did, and then I'm going to stop there. Okay, to start with, like, what is high value manufacturing? So there are different terminology used in different countries. So in UK we say high value manufacturing, whereas in the Asia they say advanced manufacturing. It's what it is exactly. It's how they are going to apply leading edge technical knowledge and expertise in terms of product design, process design, and the associated services. Like mostly I mean associated services, how we are going to customize according to the need of the individual. It could be based on the process, or it could be based on the product. I'm going to show some of the example of what is hyper customization. So it's nothing but how we are going to apply technical knowledge. So whatever you study in mechanical engineering, how you are going to be like more contemporary practices you're going to evolve, or what kind of inefficiencies you are going to fix it, and how we are going to create a new product which is contemporary in nature. So typically, like it could be design, manufacturing, or thermal, whatever it is. So I'm just on a holistic basis, I'm saying how we are going to design a product or a process and associated services. So how we are going to digitize your knowledge and cater to the needs of the industry. So typically, I am talking high value manufacturing will not be applicable to all. So I'm not talking about automotive here. I'm talking about aerospace, marine, medical equipment, including pharmaceuticals. So these industry are called as like are suitable for high value manufacturing, meaning the returns what they get based on the innovations what they do in terms of products, process, and services. So aerospace, we all know it's a project-based industry, and it takes like years to build the aircraft. What kind of innovations they are going to trying to do? If you take, for example, Boeing or Airbus, they used to have like 10,000 suppliers. So how they work with these suppliers, how they manage to supplies, how they derive innovation from the suppliers. So also, I'm not talking about smartphones, which is not an high value manufacturing at all. I'm just talking about aerospace, marine, and medical equipment, for the effort and for the emerging challenges, we can't apply the same practices, same design. We can't mass produce here. Things are changing quite frequently, rapidly. So how this has to be configured, and how your knowledge could be used to come up with some kind of new products, new processes. That's what I am trying to refer to here. So right now, you might have seen in the medical industry, like because of this COVID, like how that is like how they develop this vaccine in a year, which is phenomenal, which is highly innovative. The way in which the technology supported the medical experts, like for example, in coming out this vaccine in less than a year, so which is highly impossible like 10 years ago. So why people are interested in this in the sector? Because it contributes, it employs around, the contributions are substantial, I would say. It employs around 3 million people. If, for example, I'm talking only from the UK point of view. So UK is like Tamil Nadu in terms of population. So there around 3 million people have been engaged in this sector. It could be high-speed train, it could be aerospace, it could be marine, or it could be pharmaceutical, and it constitutes 10% of value added. So this is contributing to 10% of GDP growth in the UK. So this sector, high value manufacturing sector, these three sectors I'm referring to, which is something, if you want to put it in terms of like numbers, it should be like 360 billion pounds. So that's a big like sector here. So they have a separate catapult they call like high value manufacturing, which is a group where it's funded by government. Also, it's the main role of this kind of agencies are to pull up the industry, support industry. They will try to moderate the interaction between universities and industry, kind of thing, like knowledge sharing will take place, and then they will try to keep updated on both sides, both industry as well as university. So the challenge right now, what we have seen in the sector is shortage of trained manpower. So they're struggling to hire. If you see, look at the webs the job portals. It could be, I don't know, you guys might have heard about Indeed or LinkedIn now, emerging Google Jobs or whatever it is. So if you go and see like high value manufacturing, there are many highly there is many ads, I would say, like job ads, which are expecting a lot of skills out of, like, it's not in terms of experience, in terms of exposure, in terms of training, in terms of certification, what they got. So that if you possess those kind of skill sets, it is you will get multiple jobs. That's what we are seeing right now in the UK. So again, like if this is from a report we took, we tried to understand, like, okay, we talked a lot about industry 4.0. So what is the problem? Why companies still struggling to implement industry 4.0? What I mean by industry 4.0 is it includes cyber physical interaction, it includes artificial intelligence, it includes like cloud computing, big data analytics. So if I say industry 4, so how we are going to leverage those kind of technologies in terms of product, process, and service development. So that is what I'm referring. So when we looked at the survey recently, what we found out is the number one barrier in terms of implementing industry 4.0 is lack of qualified employees. So that is a big impediment what companies are right now facing. So There is no qualified employees who can employable graduates for the company point of view. So that is what reported by all the senior managers in the company. So there are other things in addition to lack of qualified employees. There are cost, unclear, because they have to take a risk. These are new technologies. It could so unclear return on investment, or it could be on cyber security, data integration, access. But why I'm showing this slide to you guys is, if you realize that you have a lot of value, and if you equip yourself with the right skill set, there is a huge scope of potential of, like, there is a huge scope for you guys to get a lot of job in the market. So that is what it is. So as I said earlier, like, we looked at like some of the leading portals like LinkedIn and Indeed. It's interesting, in India also LinkedIn is picking up. That's phenomenal. Here everybody like post the stories, what they do, what are they achieve professionally. It is not like Facebook. It's more like, you guys might know, it's a professional platform where to share your work related kind of achievements, contributions, recognition, what you got out of it. So Indeed is typically it's a job portal in the UK, for example. It's more like context oriented. I don't know in India what you have right now for job searching platform, but we have several others like Google Jobs. But people mostly, if they want to look for a job, they look at LinkedIn or Indeed or Glassdoor. We do have something called Glassdoor. So what we did for this understanding, like to understand what is the requirement of job, especially for high value manufacturing sector. Typically, I am referring to the three industries like which I shared with you, like aerospace, marine, and pharmaceutical or medical equipments. So medical equipment meaning it's more scanners, kind of things. Like CT scanners and things like that. That's what I'm referring to. Plus, pharmaceutical industry is new drug development, which is a lengthy process. So we did a few searches on this job portal, and from the electrical sector, we found out senior manager they need for advanced manufacturing. So they are what skill sets they are expecting you to possess, something like Industry 4.0, flexible automation and machine learning, smart digital technology, capex planning, capital expenditure planning, smart factories, the throughput. Sorry, there is a typo here. So it's smart factories, the throughput. These are the things they are expecting you to know. Likewise, we did an electrical sector where they say they need potential employees who have some right skill set in terms of data analytics, machine learning, additive manufacturing, Six Sigma. Still, you can see, even though lean production, Toyota production systems, we say it is dated, but still companies are expecting you to possess some skill sets in terms of achieving excellence. Understanding IT infrastructure in system integration. So it's more interdisciplinary. It is getting interdisciplinary. You can't get a score like job based on your manufacturing skill set. So you need to have like depth knowledge about manufacturing, but associated knowledge in terms of IT, digital technologies. So that would help you a lot over time. And if you say, for example, we looked at aerospace, they are looking for industry they call I 4.0 manufacturing organization skill sets. They need to know how to create a smart factory, manage smart factory. So we do have a lot of warehouses in India. Also, it is picking up the e-commerce. All the warehouses are fully automated, for example, which is fully manned by robots without any human intervention. So we have a couple of Ocado retailer. They have a fully automated, 100% automated warehouse where picking, placing, packing, everything done by robots without any human intervention. So they look for machine learning capability, big data analytics. This is what they need in the aerospace sector. So this is to give you an overview of where there is a lot of job for you guys. So don't stick on to conventional automotive kind of job or going to traditional IT companies, but there are other avenues for you, associated avenues for you. So what I mean by innovation, I said like supply chain. We talked about what is high value manufacturing. I will try to take you through what is supply chain, then innovations. What is the innovation? Why we need innovation? Innovation is a key thing for companies to compete with others. So it could be in any sector. Innovation is going to take you further, like in terms of like in the long term. So if you want to adapt industry 4 capabilities, so what we need to do, for example, they single company can't do. If you take for example Apple supply chain, they have like the globally they have interconnected supply chain. Germany is contributing towards chip development. For example, Taiwan is contributing in semiconductor industry. Japan is contributing in terms of like, so each country has own skill sets which has to be interconnected in order to achieve things. So what I'm saying is they have a massive complex supply chain. So certain component knowledge is with certain people, like it could be Intel or it could be Qualcomm or it could be manufacturing capability could be from Foxconn. With now we do have a facility in Chennai to do this. So they have massive complex supply chain. How they are going to leverage their potential in order to achieve the necessary kind of like the gain what they're expecting out of this. So they need to share information with wider supply chain partners. They need to reconfigure product and process innovation and integrate with business process system. They need to enhance supplier capital. They need to train supplier capital. They need to put time and effort to invest. They need to invest time and effort to train supplier capability. So that is what it is. So typically, like adoption of Industry 4.5, we have seen in a couple of slides ago, there are a number of barriers or issues, challenges right now they have in terms of implementing Industry 4. But beyond this, companies are coming out some kind of innovations to take out to deal with those kind of barriers. So since I said like this project is from the partners of this project are from China, 3 universities are participating, and the National University of Singapore is also part of it. So we also looked at the innovation scenario. I'm also happy to note from India, they are also now emerging in terms of innovation. So if you take in terms of innovation ranking, is based on number of factors. It includes patents, it includes research outputs, like traditionally what they count in terms of top journals, and then the new product outcome. So Singapore is ranked top 10 in the world in terms of innovation ranking, and China now it's in 20. But India, we are far down, so it needs some time to cope up and catch up with these countries. But you may ask this question, where is UK? UK is also slided down a lot recently, but now the government are supporting companies with a lot of funding to make this interaction possible between university and industry. So we will see what are the innovations made in HVM so far and what is possible in the future. And also we are asking these questions. Are universities in the UK, for example, we know there is a shortage of manpower. So the main feeder for this or main kind of like supplier of these manpower is universities and colleges, higher education sector, and how they are geared up to fill this gap. That's what we are trying to see from this study. So our universities in the UK prepare graduates with relevant knowledge and skill for their career in high value manufacturing supply chain. So we say that, okay, we know that there is a problem there, or the universities are changing their curriculum, or they are very like they are more foreseeable and they're well prepared. They're more like future looking in terms of preparing graduates. But yeah, many universities have done in the UK as well as globally, but still a long way to go to fill this gap. What we did a systematic literature review to identify. We looked at, from the supply side, we looked at the research, what is happening at the universities, what are the courses they do offer. From the demand side, like mostly industry, we interacted with companies. We also looked at the job portals, and also we looked at we had a consultation with few companies to find out what exactly they need. Okay, so basically for us, the aim is to gain an overview and an understanding of innovation and supply chain through literature, what is happening from the supply side. Yeah, universities are doing great research Are they being commercialized? Are they being used in the companies? Are they being reflected in the course, what they teach? That's what our aim to do. So we try to identify innovative process and products. Through this literature, we are able to find out what is happening. We are how they adapt this new innovation. What are the trends available in high value manufacturing supply chains? How they synthesize this innovation and try to train people based on what the research they do. And also we need to be from the from the university side, like we see what courses they teach, how they train people, what kind of new modules they have, like we say courses they offer, whether it will help students to gain those shortage skill sets. So typically, to make it very simple, I don't want to make it very complex. So what we did is we looked at the current innovation covered in the literature from the research point of view, and we also looked at the various universities, top universities in the UK. So based on the ranking, so no other go. So we had to go and see the Times Higher Education ranking, QS ranking, and other things, and then we have league tables like Ivy League. We have Russell Group league tables. So we looked at all those universities, what courses they offer, what modules they teach to students to train students, and also what are the expectations of the industry, how they adapt those innovations. So these are the three things we tried to do in this study. So to start with, I said we did a literature review to understand the innovation. So we looked for the three keywords here: supply chain, high value manufacturing, and innovation. We used a different search string, and we also for innovation we use technology, advancement, disruption, industry 4.0. For high value manufacturing, we also say different countries referred. For example, go to Singapore, they say like advanced manufacturing. US, they say advanced manufacturing. So we used a smart. So US, they say smart manufacturing. Sorry. So so we use different terminologies to get to know what is happening in high value manufacturing. For supply chain, we looked at all stages of supply chain, starting from procurement, manufacturing, services, distribution, warehousing, and then systems engineering. In people like in the Singapore, there's a systems engineering which is very popular. So in transportation, so these are the keywords we looked for. What we got, so typically like we first place for academics to look for is the literature. To do a literature is the Scopus and Web of Science. So when we used this search string, we got 23,000 papers in Scopus, something around 12,000 papers in Web of Science. Then we used multiple inclusion and exclusion criteria, where we said like we need to have look only the research that has been published in high quality journal based on certain ranking. Also, we focused more on innovation. For other papers, we rejected. And finally, we got to know something like 50 to 60 papers we got exactly meeting our criteria. And then we literally gone through all those papers to understand what is high value manufacturing innovation. So typically what kind of journals we looked into? So production research, production economics, transactional system management, cybernetics, production operations management. These are journals which had all the flavors of supply chain, innovation, and high value manufacturing. And we also got, so whenever we do the systematic reviews, we need to let people know the descriptive statistics, what we got out of this. So the papers, as you can see, we stopped at the mid of 2021. So if you have seen, and now the papers, there are multifold increase in terms of publication. So it's picking up. From in the universities are doing great research. Researchers are doing great. They're trying to publish a lot of new thoughts and new empirical evidence or new experiments based on what they do with respect to high value manufacturing. So in terms of product, you may ask, what are the new things? So now people are talking more about the hyper customized sole. Like I think you guys might have seen, this is smart soles where it can sense your walking behavior, and it can change shapes and things like that. So this is one kind of a new product what we have seen in terms of innovation that has been made from the product side to the customer. This is more like you might have heard about Foot Locker is a distribution chain, and Adidas and Foot Locker were jointly working. They wanted to customize the shoes, because right now what shoe we use, like I don't know, in India I forgot the sizes right now. In UK we say like 8, 9, 10. Those are standard size. It is not according to our individual feet shape. So each individual has a different feet shape. So technically what these guys, Adidas and Foot Locker, did is they scanned all the feet, and then so if you go to a Foot Locker retail outlet, they use a 3D printing, they scan your feet, and then they will, in 30 minutes, they will produce a sole which exactly matches your feet shape, and it will fit your size. So it is not you're not using standard size, it is more personalized shape and size, which gives more comfort for your walking as well as safe for you to use those kind of footwear. So this is typically an innovation that has been done, and recently there are a lot of intelligence being made to monitor your walking behavior, the angle, the shape, how you do, so that they wanted to provide more comfort and convenience to the individual. So at the individual level they are doing, it's not like a mass standardization. I don't know how many of you heard about this 4D printing. This is what it is exactly they did with this product. So I can share you what is 4D printing if I have time, please. I'll stop sharing. So this is interesting. Can you see my screen, please?
It's not visible.
I'm just trying to show a YouTube video. So
Yeah.
literally, because this platform is new for me. Let me try again. Okay. So is it visible now?
Yeah.
Sorry, this platform is new. I'm new to this platform. So normally we use Zoom and Teams. Anyway.
In a nutshell, 4D printing refers to 3D printed objects that have the ability to reshape or self-assemble over time. Now, we recognise that's quite a complicated nutshell to get your head around, so here's a bit more detail. 4D printing was born out of the self-assembly lab established by Skylar Tibbets at the Massachusetts Institute of Technology, or MIT. It was a concept he developed alongside Stratasys and Autodesk. It involves strategically positioning rigid and expandable materials next to each other within one 3D printed component. When the expandable materials come into contact with water, they grow up to 200% of their original volume, changing their shape and effectively repositioning the rigid materials either side of them. The expandable materials effectively create joints in the components that are activated in certain conditions, causing the entire component to adopt a different form. Depending on the expandable material used, the contact substance necessary for it to change shape could be water, or it could be heat, light, or a range of other simple energy inputs. Software enables components to be programmed on screen before they are created, and for that data to have effectively been programmed into the component once it's been created. Going beyond this range of small-scale demonstration pieces, it's thought the technology could be used in some form of self-repairing water pipes, in pipework that changes size in relation to water flow, or in hot and cold temperature water valves. Beyond plumbing, it also has potential in medicine, clothing and footwear that adapt to climatic conditions, or in childcare products that respond to temperature changes. If you enjoyed this video and would like to get more from the Definitive Video Channel for Construction.
So I'm stop sharing this. So this is a typical application of 4D printing, which is evolving right now. which is programmed. The materials are like kind of programmed, which can change shape. So we all know what is 3D. 3D is more like additive process, whereas 4D is we are trying to build intelligence in a material which could sense according to the external influence, whether it could be climatic conditions or it could be other factors like force, pressure, light, source, or whatever it is. According to that, it will change its shape so that it gives comfort to the user, kind of. So that is emerging recently. Like as you've seen in the video, there are a number of other examples available for 4D printing, which is emerging, which is a process innovation. I would call here. Where I am. Okay. So typically, like we all know, 3D printing is static structure, whereas 4D printing, where we have dynamic intelligent structure, which can change shape based on external climatic conditions or number of other factors. It could be pressure, or it could be based on heat, it could be based on light, etc. So there are so again, people wanted to use this technology. As I've shown you earlier, there are a number of impediments like barriers they used to have. So recently, we all know only for 3D printing side, laser technologies, flash technologies, extrusion technologies, jet technology, lamination and cutting technologies are quite popular. This is from 3D side. So how we are going to use the material which is programmed, which could be used during this technology to produce the required product. So that is a key thing right now emerging in manufacturing side. So I was saying something about innovative practices. So we looked at all the practices from end-to-end supply chain point of view. So we looked at robotics and automation. What they do, they come up with programmable manufacturing advisor, which is like in Tesla they use quite effectively, and then it is fully automated, and then which is more dynamic in making decisions if something changes. Cyber physical systems, there are a lot of innovation, but because of time, I'm not going through. There are a lot of details within each topic, but I'm not going through each one of them. So I'm just giving a flavor of what is happening right now for you guys. It's kind of an eye-opener for you to go see what is happening and how you think your strength matches with this requirement, and how you can build up your capability. So that my objective is to make you aware of what is going on, and the rest of them is with you to learn and then to equip yourself. So there are plenty of opportunity available within the company. So in terms of big data analytics, intelligent automation, that's what they're looking for. In terms of Internet of Things, how you can achieve indoor localization systems to find the nearest mission. So it's kind of like sensing and taking action when there is a mission-to-mission interaction. And then in terms of simulation modeling, digital twins, which is more like modeling physical system. We do like a prototyping, like CAD prototyping, how we have physical as well as digital prototype, where you can experiment different things with the digital prototype with the help of AI to replicate in the real system. So blockchains, it's a big topic to talk about. Again, even though it looks like very simple, like a digital ledger technology, but now the application has picked up. Now, I'm not talking about Bitcoin or cryptocurrency here. It is more about how you are going to use a blockchain like RFID in order to track and trace in supply chain, so that people get the authenticity of the product, where it comes from. It gives more trust it eliminates all the intermediaries in the supply chain, as well as it will give more transparency in terms of movement, in terms of tracking, in terms of understanding the authenticity of the material, where it comes from. Are we consuming the right product or using the right quantity of product, etc. So artificial intelligence, I don't want to say that is going to be the number one dominating skill set where companies are expecting from the students to do. Machine learning algorithm to predict interferences in advanced manufacturing processes, such as vibration that is normally affecting quality. So and then in terms of cloud computing, like cloud platforms for advanced manufacturing. So because all this in future, people think every house is going to have a 3D printers, and in that case we need to buy the design from the manufacturer, and materials we will buy this composite or whatever this fibers from different sources, and we will try to produce a product from the using cloud-based design available from the manufacturer. So that is key. How to avoid hacking, security threats, all those things are key challenges. And in terms of like visualization, like avatars, like Meta, they say Meta, and they wanted to give a real feeling. So we all converted, like fortunately or unfortunately, I would say this pandemic made us to buy a lot of stuff from online. Especially also people used to go to store, feel the experience. Now with this kind of online thing, they are trying to bring the real shopping experience through avatars and through Meta. They are trying to do this now. So I think you might have heard about the story about what Facebook is doing, what Google is doing. So it's more about getting, so by staying at home, getting a physical experience of how you go to shop, feel, sense, and buy some products. So that is what they're trying to bring. So which needs a lot of training and skill sets from the graduates to support these activities. So we looked at the different stages of supply chain, what is happening at the supply end, how suppliers are equipped with that, what kind of shortages they do have, and what kind of innovations they have. In procurement, how they use blockchains, that is the one innovation, like how they produce smart contracts in buying. In manufacturing, we thought like how, because it's no more batch production or mass production, nothing. Now they are trying to think about how to combine these in order to come out with some hyper customized products. So each individual is a customer now. So each individual is a batch or so we need to have a different there is a different requirement for different individual, how we are going to configure. So how we are going to schedule, how we are going to make machines more intelligent, how in this kind of scenario, how we are going to ensure quality and consistency, and what you do with this multiple variations. So we are increasing complexity, how we are going to get this. It's not a standard process, it is more like unique process for different individuals, and there is a variability is so high, how we are going to achieve consistency. That is a great challenge right now. In terms of delivery, warehousing, all the retail outlets are going to become very soon warehouse. How we are going to automate warehouse, how we are going to use big data where customers express their feelings and views, they share their thoughts using social media platform, how we are going to crunch those data and try to make some useful decisions in terms of for manufacturers to understand the customer. And again, the circular economy, because of climate change, how we are going to treat the end of life products. So that is a big challenge right now throughout the world. So these skill sets are needed from a supply chain point of view. So I try to run through you with what innovations is taking place, what universities are doing research, what is high value manufacturing. Typically, I was trying to run through with what are the product process innovations happening, and in terms of supply chain, what is happening. So typically, IoT, big data analytics, cloud is mostly combined with other technologies, but there is a need for big data and AI applications. Certainly, that's what we have seen from the reviews and as well as consultation. And typically, the question lies before us is like how to build a smart supply chain from the current smart factory concept. So we previously we focused on one entity, one manufacturing facility, but how we are going to make the supply chain smarter. Like as I said, if you take Apple, they have a global complex supply chain. So how we are going to make all the entities in the supply chain more smarter. So it's automatically connecting each other, reducing human intervention, making more intelligent in terms of taking action. And if there is a disaster, so we know that in every 3 to 4 years there is going to be some kind of disaster. How we are going to cope up with all those kind of uncertainties, all these things, if you can address, then that's what we call smart supply chain. That's where people, researchers are geared up to deal with, as well as companies are also need manpower from these kind of skill sets where they can address some of the challenges what they do have right now. We also looked at some of the courses. So we found out from these are the courses which has more elements what companies are expecting. For example, University of Wales, they do advanced manufacturing system, MSc. They cover most of the aspects what I have discussed with you guys. University of Port, I'm not advertising any university here. I'm just telling you what is happening in the university in the UK. because we looked at demand side, we also need to look at the supply side. So from Portsmouth, they do advanced manufacturing technology where they cover a lot of these skill sets. The University of Exeter, they do a lot of technology ventures and innovation management. In that course, they cover most of the things what industry expecting. Likewise, Strathclyde, they do digital manufacturing. So that is they are a bit advanced in terms of what they're offering. So typically, you might have seen like there are 200 universities in the UK, like more than like 150 to 200 universities, but only 4 universities are offering courses which exactly what companies need, and others are trying to now catch up. In addition, there are a number of other online courses available from Coursera or from MIT and things like that. So there are several online courses. In future, people predict there is going to be more personalized learning clouds are going to appear, where universities and different online providers are going to interact and offer microcredit based courses to satisfy this need. So sorry, I took a lot of time. I'll stop here and try to answer if you have any questions.
Dr. Nachi, I think one participant he left some questions in the chat box.
Right. I need to.
Yeah.
Okay. So chat. Okay. Right. So there is a question from Elil Maran.
Yeah.
Right. Challenges in implementing Industry 4 will be overcome by introducing new technologies, new subjects, university syllabus with more practical knowledge, sir. So all the whatever I have shown you, the 4 universities at the end, so they are more like practice-based delivery. So now all the universities, especially in the UK, it's not theory kind of like pushing theories to the students. It's more practice-driven courses they are offering, meaning they engage with companies. They try to design the curriculum in a way that it meets the requirements of the company, as well as they have made sure that they are more critical, creative, and they try to encourage in different ways. It's not asking people to come and deliver a lecture. It is beyond that, kind of like that is what it is happening. What I'm seeing in the UK, it's more practice driven, I would say. Yes, it's not a theory driven. It's both. They are making trade off in terms of combining theoretical plus practical knowledge, what they offer. So you may think that engineering colleges are doing that, but beyond that, universities are facilitating for students and company people to interact and to tease out some kind of new innovations. That's what it is happening here right now. There is another question from Muthu Selvam already. Hello, what will be the session start? Okay, so there are no other questions. If you have any other questions, I'm happy to answer.
In question and answer section, there are 3 more questions for that.
I have seen chat. There is question and answer session. I didn't see any question and answer.
Can I read it?
Yes, please go ahead. Yeah. Oh, okay. I can see question and answer. Right. So in India, the professors are working with industry is very less. The faculty members know the need for Industry 4, then only the students will be trained. Yeah, this is a global problem, so it's not in India. So it depends on kind of a need. So yeah, in the US mostly like a lot of industry work interact with university, but in other countries little less, but it is a bit challenging everywhere. It is not easy to interact with companies. Don't want to spend time, which is more like they're more commercial. Okay, so every minute is a money for them. So they wanted to interact if they get something out of the interaction. Otherwise, it's all more outcome driven from the company point of view. It's a bit challenging if there is a push from universities or colleges, as well as push from the government, and there is a bit of push from companies, then certainly the kind of interaction will happen. So it is a bit difficult, challenging, but we interact with companies. They are a bit open in terms of sharing their challenges with us. So, but still a lot of effort has to be put from the faculty from the individual's point of view. So they need to convince the company that they are capable of delivering what they're expecting. So that takes time. That takes a bit of effort from both sides. Right, that's a challenge, global challenge. So then I can see one question: what kind of syllabus change? So syllabus change is very detailed. So I didn't take you through the syllabus change because we did a detailed analysis of what needs to be incorporated within each subject we call module. So in each subject, what changes has to be done. That's what we are doing right now, which is I'm not sharing, which I can't share right now openly. What this will go to as a finding to the project funders. Challenges for implementing Industry 4.0 need more weightage on practical. So, see, there are a number of avenues. If you think something is opportunity, there are a number of avenues for people. I've seen a lot of Indian students. They do, in addition to what they learn from the university or college, they do additional skill set development by attending online courses like microcredit courses from MIT. There are many open free courses available, Coursera, MIT, and other short courses which will give you an awareness of what it is, and especially for data science or digital capabilities or kind of if you want to do open GUI based artificial learning, all these things are possible right now. So it's all based on individuals' intuition, intention, motivation to do those kind of things. If you can showcase that you can do that, then certainly there are once company hires you, they will try to train you. If you have right attitude, right kind of exposure, ability to master something, it is easy for them to train and put you into the task. So which is not a big deal. So thing is it has to come from the individual. But yeah, there are detailed course level changes we have noticed, but I can't share right now because it's an ongoing project for me.
Okay. Participants, if you have any other questions.
So I just touched upon some of the challenges, but I didn't go in depth because of the time constraint. Also, I can't share all details what we did so far. But still, if you're interested, I can take it offline and discuss. Okay, so
Yeah.
that is also possible. But
Sure,
yeah,
sure. Okay. Any other questions, participants? Okay. Thank you very much, Dr. Nachi. Thank you very much for sharing your British Council project, from which all our participants will come to know the flavors flavors of IoT, big data, AI, supply chain management, 3D and 4D printing, and so on. Gopika, please find out.